Okay, so in this video, we're going to go over something called perpendicular bisectors, and it's particularly useful when we're talking about triangles. And in particular, it's also useful when we're talking about either isosceles or right triangles or equilateral triangles. Now, I'm going to pretend that this is an isosceles triangle, okay? Let me just write that in there. So this is an isosceles triangle. And remember what an isosceles triangle is. It means that this side and this side are congruent or equal, all right? So they're the same lengths. So if we were to write this more formally, we would say that line segment AB is equal to line segment AC, okay? Now the perpendicular bisector theorem says basically this, and it's two words in here, so it's really kind of a two-part thing. If I were to draw a line, and remember that a line goes on for infinity, okay? If I were to draw a line through the line segment BC, I would create a bisector. It means that I've divided this into two equal lengths. All right, so let's call this point D. So basically what the bisector is BD, line segment BD, is equal to line segment CD. But that's not all. Okay, so the bisector means that, two equal lengths. The perpendicular now means that I have formed a 90-degree angle. Okay? So the perpendicular, and this is the symbol for perpendicular, by the way, so if you ever see that, that's what that means, that this forms a 90-degree angle. Okay, well, so what? That's interesting, right? But here's where it's interesting about this. That means that any point on this line, and let's just create a few points here, okay? And let's even do that one. That means that any point on this line is also equally distant from the two ends of the line segment. That means if I were to draw that, and I'd have to give this a label, let's call that E, that means that line segment BE would be equal to line segment CE. That means that line segment AB would be equal to line segment CA. ABAC, right? Try to keep things symmetrical. And so on and so forth. And actually even down here. Okay? And we just call this one like F. That means, again, that line segment BF, oops, I had an A there. Line segment BF would be equal to line segment CF. So again, that any point on the perpendicular bisector is equally distant, all right, from either end of the original line segment, which means that I'm creating just a series of isosceles triangles. Okay, so I hope that's helpful for you.